Thank you for joining us on today's program, Economy Watch, a program designed to keep you abreast with the economic landscape of our country. And today we'll be talking on the place of TCN, the Transmission Company of Nigeria, in contributing to the economy of our nation. My name is Ofrom Stephen. And to do justice to this topic today, we'll be speaking with an energy guru, the Executive Director, Transmission Service Provider, TSP, Engineer Oluwagbenga Ajiboye. Sir, welcome to the program.
Thank you very much. You are welcome. Transmission Company of Nigeria, as it's called, TCN, is one of the company of NEPA when it was unbundled. In the old NEPA, we have three sectors, that is generation, transmission, and distribution. The GENCO has been splitted and sold to different private entities, while transmission, the operator of the grid, is maintained as one due to strategic importance of the infrastructure, while the DISCOs are 11, also sold to different. So the function and the role of TCN is to transport the bulk power from the GENCO to the distribution. So presently, we have about three roles: as a transporter, as grid manager, and as the market operator that collates all the funds in the market and share them. That is the function of TCN as a whole now. While TSP is the operator of the grid, the manager of the grid, and the ISO are the one that coordinate the grid. So if you look at TCN, we have two sectors also, TSP and ISO. Well, presently, the function of the Transmission Company of Nigeria is where it's based on what we do. The ability to be able to evacuate all required power from the GENCO to the distribution. So the meaning is this: we need to improve on our infrastructure, the transmission line capacity and the transformation capacity. The transformation capacity is what evolves the transformer. By changing the voltage level, we transmit on higher voltage of 330, 132 to reduce losses in the grid. And we now step it down at major substation for the off-taker, that is the DISCO, to be able to take the power in manageable voltage, which is not dangerous to the people that are going to utilize it. So based on that function, we need to develop more of the transmission line to be able to cover a lot of area. Though we have covered so many kilometers in Nigeria, we have 330 line radiating over 5,000 kilometers, 132 about 11 to 15,000 kilometers. So these are the things we are developing. And the transformation capacity, from the first quarter to this time we are talking about, we have added over 1,300 MVA capacity, which is very big. That is, when we are talking of big transformer, we are talking of 300 MVA, which is one we have commissioned, 150 MVA, about 3. We have done about 100. Total now, we have done more transformer in the first and second quarter, and we are still continuing because we keep on commissioning every day. So also, we are trying to do line, but the line has a lot of problem in the sense that we have issue of right of way. You will be working on lines. It will get to a point you will not be able to progress because the community will stop you, that you need to pay them for you to be able to plant one tower. So that is being held down. So in another way to be able to circumvent that, what we now do in the TCN is to concentrate on the available line and be able to reinforce them to be able to win more capacity. That is what we call reconducting of those lines. In the area, we cannot even get way to do another new lines. So the reconducting, because of the development in technology, we now have conductor that can carry triple the capacity of the one we have used. So we drop the old one and put those capacity. Instead of doing another line, we'll be able to carry the triple capacity of the one that was existing. That is what we are now functioning and looking at to be able to wheel more power to heavily demanded area.
All right. Currently, what is our transmission capacity, and how do you intend to improve it in the future?
Presently, we have what we call static capacity that we know. That is only determined by study. TCN capacity of over 8,000, close to 9,000 megawatts. So the meaning is this: when I say static capacity, it's a simulation. And presently, we are discussing that we can wheel 8,600 megawatts, which we are convenient with. That is what we can wheel now. But it's a bit tricky in the sense that you need to put all the generation available and the disco ready to take it. But that is not happening now. What we have now in the market, even if we have the generation there, the distribution are not ready to take it due to the buying power of the populace.
All right. We always hear that there is a collapse in the national grid. We know that there are infrastructures that's supposed to be in place to make sure the national grid does not collapse. Can you tell us what is responsible for often collapse of the national grid, and how are you working to strengthen the capacity?
Well, thank you very much for that question. Though the question is directed to TCN, but let me tell you the way it operates. When we lose equilibrium in the system is when we have system collapse. The meaning is this: the energy we generated is not being stored anywhere. That is, I only take as TCN whatever the disco are ready to take from me. I collect it from the generation. So when we are talking, so many factors can cause system collapse. So if the disco are not ready to take the power and we have sudden disparity in the generation and the distribution, there will be a mismatch. And this mismatch can come in two ways. It's either if the disco is higher and the generation is low, we experience what we call under frequency. When we have under frequency, though we have measure in place to be able to take care of that, but if the decay is so fast in such a way that those measures will be defeated and I will not be able to undo it, there will be system collapse. So the unit will trip and we need to restart them. That is when we have total system collapse, when there will not be any light in any part of the grid. And again, if we are generating, the disco is taking the energy, suddenly a transmission line carrying higher capacity trip, it can lead to system collapse. Because the generator in that axis will be disconnected suddenly from the grid, and it will lead to under frequency, and all the machine will go down. Another scenario is this: when we are working, transmission might not have problem, distribution might not have problem, but if a machine trip in the disco, in the generation, that is also higher capacity, that the grid cannot accept, so there is going to be problem. So how can we ameliorate? Let me be analyzing it this way. The first, let me start from the generation, then come to disco. One thing is very sure: for you to bring your machine to the grid, you need to ask what we call free governor. The meaning is this: when we are losing disco's load, your machine should be able to ramp down. When disco is putting more load, you should be able to go up without anybody touching the machine. Are they functioning? We need to ask ourselves that question. Most of them are not functioning. So based on that, we can see the problem the generation can cause by not having free governance, or by not activating free governance on their system. Where the problem from transmission can come is this: we're supposed to have complete SCADA monitoring everybody, both the generation, the transmission, and the disco load. We don't have effective one now. We are still working to make sure it covers the whole Nigeria, because every equipment, every line that comes to the grid must be seen and monitored. That is not viable now. It's not effective 100%. That percentage is very low. So few machines, few equipment are visible to the controller, that is NCC. So based on that, they cannot see in a clear way what is happening on the grid everywhere. So that is the aspect of transmission. When you now go to disco, the major problem we have is this. Take, for example, I'm wheeling about 200 megawatts to Abuja, and rain started falling. The load just suddenly dropped to 60 megawatts. It is too much. So when we are talking about everybody have a share in the system collapse, it's not limited to TCN, but because TCN is the manager of the grid, is the owner of the grid, is seen as if his own grid has collapsed, that is the one responsible. It's not always true every time. So every other sector must wrap up effort to make sure they put in place measures required by them to be able to manage the grid. As the GenCo have their own, transmission have their own, and DISCO have their own. You don't expect when there is rainfall for a feeder to trip. It's not normal. It's an abnormal. So you're supposed to have light either it's raining or not. But in a situation whereby we lose all the 33 kV feeder or 11 kV feeder during rainfall, and there is nothing for generation to feed, they have to quickly ramp down. And sometimes if it's not incremental, if it's sudden, the generation will lose synchronism and they will also trip, either over frequency, if the load had dropped suddenly, or if it's generation that went down on that frequency. So it happens that way. It is so systematic that everybody have to put everything in place to be able to work and be able to achieve balanced grid.
This is Economy Watch, and we'll be drawing the curtain here. Today we'll be speaking with an energy guru, the Executive Director, Transmission Service Provider, TSP, Engineer Oluwagbenga Ajiboye. Sir, thank you for giving us audience.
Thank you, sir.